Hi guys, it's Miss Redican here. I'm sorry I'm out today. I will be back tomorrow, but here is your lesson. Follow along with me and fill in your worksheet as you go, as well as answer the questions in the Ed puzzle. And here we go. So, when we look at the periodic table, you might not notice obvious patterns. So, we're going to start with something that is a little more obvious. So, take a minute and take a look at the puzzle. What do you think the missing piece should look like? Pause the video if you need to. Think about what shape the body should be, what kind of hair it should have, what kind of fingers it should have, things like that. Okay, so let's take a look at the answer. And there we go. I know my drawing skills, no bounds. So again, we notice that if it's in this row, it will be bald and have three fingers. Sorry, this column, I should say. And if it's in this row, it will have a round or oval shaped body. So notice there's different patterns going vertically than horizontally, and that's true of the real periodic table as well. So this is Mendeleev. He was a Russian professor, and he was looking for a way for students to learn and understand the elements more quickly. He came up with the periodic table. Okay? Now he gets the credit. However, there were other scientists that created charts of elements organized in different ways, in circles, in triads, but his became the given or the staple or the foundation. Right at that time, there was only 56 elements around, and he put each element and their properties on a card, and kind of kept playing around with them and organizing these cards until he came up with some patterns. And from that, he was able to predict elements that hadn't even been discovered. He predicted their density, their color, their reactivity. Right? So he didn't know when they were going to be discovered, but he knew what they were going to be like. And he left spaces for them. And that's why his table ended up being the one that gets the credit and then becomes the foundation for our modern table. Okay. And his predictions were pretty spot on. The word periodic might not mean what you think it does. Periodic means occurring in regular intervals, in regular, predictable intervals. It does not mean, whenever or occasionally. An example, women get their period periodically, about every 28 days. Okay. Now, today there are 118 elements of the periodic table, quite a few more than Mendeleev have. And 90 of them are found in nature. The others are man made, found in laboratories. Okay, let's get going. You can pause the video whenever you need to if I'm going too quickly. Now, the periodic table is organized in rows going across called periods, and the columns going down are called groups or families. Okay, so let's take a look at some patterns in the family group, those columns. So there's something we're going to learn about called valence electrons that are going to be super important because chemical reactions and life come from valence electrons doing their thing. Valence electrons are the electrons an element has in its outermost shell. And we're going to learn how to identify that as well this week. Now, elements in the same group have the same number of valence electrons, and that makes them have similar chemical properties. Similar, not exactly the same, but similar. So I'm going to take a look here at this reaction that I did, and we'll see what I mean by similar reactivity. Hi guys, it's Miss Redican here. We're going to take a look at a little experiment. We're going to compare magnesium and calcium. Magnesium is a smaller atom in group 2. Calcium is also in group 2, but it's a little bit larger. It's below magnesium. When I talk about the size, I'm talking about the size of the atoms, not the size of the chunks or pieces being used. So keep that in mind. Here we go. Let's continue. But they're both in the same group, and they both have the same valence electrons in the outer shell. We're going to see how they both react with hydrochloric acid, which is your stomach acid. Okay. So I have magnesium and calcium in there. I'm going to add the acid, and we're going to see how they react. and observe their reactivity. Okay, you can see that they are both reacting in a similar way, but not exactly the same. The magnesium is reacting. You can see bubbles of hydrogen being released. And calcium also is creating those bubbles of hydrogen. So they're reacting in a similar way, but with different intensity. Calcium is a larger atom, of course, and larger atoms hold on to outer electrons loosely. They will lose their electrons easily, and that's what's happening in this reaction. So while they're both similar in their reactivity, because they're in the same group with the same valence electrons, they're not exactly the same. That's all. Okay, so again, elements in the same family group will have similar chemical reactivity because they have the same valence electrons. Oh, wait, come back. Nope, sorry. Hi guys, it's Miss Reddy. Let me flip back here. Get back to the slideshow. There we go. And last but not least, let's take a look. Okay, so you can take a look at the periodic tables. Also, there are groups or classes. Okay? So we're going to use the word classes. I can put that in there for you. Classes. Sometimes people say the word category. I like the word classes of elements. There are metals, which are all in blue here, metalloids, and that's sort of reddish pink, and non-metals in this like yellowish color, tannish yellowish. Now you might notice there's some in white. Well, they're so short-lived in the laboratory. There's the man-made ones. They're not really considered any class. They're pretty unstable. So go ahead, make sure you're looking at this picture. Which class of elements, the metals, metalloids, or non-metals, are there more of? Hopefully you're noticing there's more metals. There's a lot more metals. In fact, 2/3 of the periodic table are metals. Now, which non-metal is weird and is on the left side of the table? Because we can see most of the non-metals are over here, but there is one non-metal on the wrong side. See if you can find it. Okay, there it is, hydrogen. Hydrogen is a non-metal. There's a reason they put it over here in group 1 because it has one valence electron. So that's why it's placed here in group 1. In fact, everything in group 1 has one valence electron. And it's placed here despite the fact that it is a non-metal and everything else in the group is a metal. Okay, we're going to learn more about metals and non-metals as the week goes on. And in fact, we're going to do a lab challenge about metals and non-metals. Now, metalloids, in case you're wondering, are sort of in between. They're a little bit like a metal and a little bit like a non-metal. Sometimes they'll be called semi-metals since they have characteristics of both. And they're kind of in between, right? Metals and non-metals on the table itself. So it kind of all goes together. Okay, so that's it for our notes today. Start working on your Jupiter Ed homework or any missing work, especially if you owe that last week's lab on stars, elements, and electrons. That was a big grade that some people did not complete. Okay, have a great rest of your day. I will see you back tomorrow. If you have any questions, feel free to email me and I will do my best to get back to you. Have a great Tuesday, guys.